Alright, so you just watched a quick video, well, not really a quick video, on identifying when to use sine, cosine, and tangent. Now we're going to have a video that's using sine, cosine, and tangent to find the sides of a triangle. So we're going to have missing sides in our triangle. We're going to use sine, cosine, or tangent to find the missing sides. So this is going to be a pretty quick video and show you how to do it, so you'll be good to go on those practice problems. So, on the left, right here, we have a right triangle. We have one side that's x, we have the 40-degree angle, and then we have the hypotenuse, which is 10. So what you want to do is you want to identify your angle. Then you want to look and see what sides they give you so you know which to use. So it looks like the x is the opposite, and we know our 10 is the hypotenuse. So opposite and hypotenuse is sine. So we know we're going to use our sine, because sine is opposite hypotenuse. So we say that the sine of 40 degrees equals opposite over hypotenuse. So x over 40, not 40, 10. So now we have our equation set up. What we now have to do is solve. And what you need to realize and remember is that the sine of 40 degrees is a number. If you type that into a calculator, it gives you a number. It's just an interesting way to represent that number right now. So because it's a number, we can add, subtract, multiply, and divide with it. So we have x divided by 10 over here, and we want to get rid of that divided by 10. So in order to get rid of a divide by 10, we're going to multiply by 10. So we're going to multiply both sides by 10. What that does is it cancels out our 10s here. So we get x equals 10 times the sine of 40. That we can put in a calculator. And we get 6.4. So I got 6.4. So the length of that side is 6.4 units. Now, when you're doing this, you can kind of check what you're doing. So we got x is 6.4, and that seems reasonable to me. Because if I look, 10 is my hypotenuse, and I know that the hypotenuse is the biggest side. So if right here I got something bigger than 10, I knew I messed up, because 10 is the biggest number I could get, and it has to be the hypotenuse. So anything I get for x has to be smaller than 10. So it's just kind of a way with these where you can check. Okay, over here on the right, we have another right triangle with an angle of 22. And then we have 6, which is the opposite, and y, which is the hypotenuse. So we're going to use sine again. So we're going to have the sine of 22 equals 6 over y. Now this one's a little bit different than the one on the left. On the right side here, we have our variable in the denominator of the fraction. So, when your variable is in the numerator of the fraction, you multiply. When your variable is in the denominator, what you're going to do is you're going to switch these two. So they switch places, and we get y equals 6 over the sine of 22, which we can just put in a calculator. And after we do that, we get 16. Okay, on to 2 more examples. Right here, we have a 62-degree angle, and then we have 7, which is adjacent, and x, which is the hypotenuse. So what we are going to do is adjacent and hypotenuse is cosine. So we're going to use cosine here. So we're going to get the cosine of 62 equals 7 over x. And because the variable is on the bottom, we're going to switch these two. So we get x equals 7 divided by the cosine of 62 degrees. We plug that in our calculator, and we get 14.9. Our other example, we have our 70 degrees, y is adjacent, 8 is the hypotenuse, so we get the cosine of 70 equals y over 8. Because our variable is in the numerator, we're going to multiply by the denominator. And if we plug 8 times the cosine of 70 in the calculator, we get 2.7. Okay, last two examples. So we just did sine, cosine, which leaves us with tangent. So we have a right triangle on the left, and our angle is 25 degrees. X is opposite, 4 is adjacent, opposite and adjacent is tangent. So we're going to do the tangent of 25 degrees equals opposite over adjacent, so x over 4. Variables in the numerator, so we're going to multiply. So x equals 4 times the tangent of 25, which is 1.9. Our last example, we have a right triangle with an angle measure of 55 degrees. 18 is opposite. Oh, work marker. There we go. And adjacent. So we get the tangent of 55 equals 18 over y. Variables on the bottom, so we switch them. Tangent of 55, and we plug that in our trusty calculator. I got 12.6. So there we go. That's how you use sine, cosine, and tangent to find missing sides.